Good morning, world. This is S. Gold back with another open source video demo. Today I'll be demonstrating the use of DynamicAnimControl to simulate rope. The strategy is simple. For physics simulation, break the rope down into short overlapping pieces, like links in a chain. For 3D visualization, generate a custom mesh by wrapping tubes around a skeleton. In this context, a skeleton means a tree of bones suitable for bone animation. We'll start with the simplest case of a slack line, a single length of rope suspended between two fixed points. Here it is in kinematic mode before any forces have been applied. Enabling a skeleton visualizer allows us to see a skeleton of 17 bones arranged in a chain. The chain is curved slightly to introduce some slack into the rope. The green dot in the center is the root bone, and the tree of bones consists of 2 branches, each with 8 bones. Switching to physics debug mode reveals that the rope is actually made up of 17 overlapping pieces, 1 for each bone. Each piece is a rigid body in blue, generated by bone and mesh data using DynamicAnimControl. And if you look closely, there's these little green arrows. They represent joints. There are 16 joints holding the pieces together, and then the ends of the slack line are pinned in place using single-ended physics joints. These pinning joints were added using the inverse kinematics interface of DynamicAnimControl. Pressing the spacebar puts the control into dynamic mode and applies the force of gravity. As you can see, the rope falls into a nice catenary curve. Pressing the X key removes the pinning joint from one end of the rope, causing it to fall. And then pressing X again removes the other pinning joint. As you can see, it's behaving very much like a real-life rope. If you use a skeleton of 4 branches instead of a skeleton of 2 branches, you get a cross-shaped rope. To generate a ring of rope, use a single-ended rope, but then splice the ends together using inverse kinematic joints. And you can also create a noose. Start with a 3-branch skeleton, pin the standing ends in place, and splice the other 2 ends together. In closing, note that both DynamicAnimControl and the demo app are part of the Minier project, which is open source. The source code resides in a GitHub repository under my GitHub username, which is Stephen Gold, StephenGold. The demo app resides in the same repository, and its file name is ropedemo.java. This is S. Gold, signing off.